In this example, we're going to take a look at how to find a graphical limit. So we want to use the graph of the function f of x to find the following if they exist. So we want the limit as x goes to 1 from the left, the limit as x goes to 1 from the right, the limit as x goes to 1, the two-sided limit, and f of 1. So here's the graph of the function. Okay. And we want the limit as x goes to 1 from the left. So we're looking right here, right, as we go to 1 from the left. So, all right, so instead of using the vertical and horizontal bars like I did, I'm just sort of going to follow along. Although if you want to do that, that's also fine on your own. But we're going to go to 1 from the left, right, so right here. And as we go to 1 from the left, following up along there, we can see that the graph, right, heads right to this point right here. So the closer and closer we get to 1 from the left, right, the closer and closer the points on the graph, and the y values are going to get to the y value of this point right here, and that point has a y value of 2. So what we would say is that the limit as x goes to 1 from the left of f of x is equal to 2. All right, next up we're going to take a look at the limit as x goes to 1 from the right. Okay, so the limit as x goes to 1 from the right, so we would be using x values that get closer and closer to here, and for those x values, right, the y values are the points in the graph as we get closer and closer to 1 from the right would be sort of following up along here, right, and those y values would be getting closer and closer to the y value where that open dot is, and that open dot is at a height or has a y value of positive 4. So what we would say is that the limit as x goes to 1 from the right of f of x is equal to positive 4. So we want the two-sided limit now as x goes to 1. And for the two-sided limit, we can see that we know both of the one-sided limits, right? They both exist, but they aren't equal to each other. So the two-sided limit in that case, when the one-sided limits are not equal to each other, the two-sided limit is automatically does not exist. So we don't even really have to look at the graph for that one because we have the one-sided limits. That tells us everything we need to know about the two-sided limit here. And the final question is, what is f of 1? Notice we don't even have the formula for this function, right, at all. And so, we have the graph, right? And so what we can do is to find out what f of 1 would be is find 1 here on the x-axis, right? And then we're going to look for the filled dot. And that filled dot is right here, and that filled dot has height 2. So the y value for an x value of 1 is equal to positive 2. All right, so that answers all of the questions. One more thing to note here, again, just in case you didn't pick up on it before, is that the limit does not care about what exactly happens at 1, right? The limit just cares about what happens to the y values as you get closer and closer to 1, either from the right or from the left or on two-sided. So as far as the open dots or filled dots go, right, they don't really change the answer for the limits at all, right? We would have followed along here the same as before. The only part we really needed the open dots and filled dots for was for this last part here where we needed to know what the function value itself was.